Well, ladies and gentlemen, this will probably have the capability of being our longest review of the year. So I'm going to try to kick it into gear here, but try not to skip too many things so you know what I'm still up to. So we're going to start with some basic right triangle trig up here at the top. Use trig ratios to find angle x. Leave answers as reduced fractions. Well, my first issue I see is I need to know what my hypotenuse is. So again, I'd use the Pythagorean theorem. 3 squared plus 6 squared would get me 9 plus 36, which is 45. But again, we want to put things as their simplified radical form. So 3 square root of 5. And then, of course, I have to use my reference angles, not the ones we use in the unit circle, but for our triangle to figure these out. So for instance, for my tangent, I'd have opposite over adjacent. 6 over 3 is 2. Sine of x, I'd look and I'd say, okay, let's see. Opposite over hypotenuse. 3 square root of 5. So I'm looking and I'm going, okay, so that's 2 of the square root of 5, but oh, that's right, I got to rationalize my denominator. So I multiply the numerator and denominator by the square root of 5, and I end up with 2 square root of 5 over 5. Cosine, again, with x adjacent over hypotenuse, and I quickly figure out it's just half as much. Those guys go away, square root of 5 over 5, and I've got my answer there. And again, if you need to take a little bit of time to work it out and show the rationalization, that's okay, but just keep plugging along. So then, cosecant, again, didn't put them in order on purpose because I don't want you getting in bad habits here. So I start looking and I go, hey, I don't have to rationalize again. Just take this one and take its reciprocal. Flip it back over. Okay. So sometimes you may not get into a bind. Secant and cosine go together. Again, back here I had 1 over the square root of 5. Flip it over. Square root of 5 over 1. And then cotangent, I take 2 and I flip it, and I get 1/2. So those are the types of movements I want to be able to make as I'm doing these. Okay. Write trig ratios and solve to find the missing side. Round answers to the nearest tenth. Reminder, when you're in this portion of it, especially if you're using one of the graphing calculators, you need to check your mode. If you're in radians, you're going to be in trouble here. You need to go to degrees. Okay. If you forget that, your answers will not be correct. I'm just telling you. And no, it's not time to leave already. So here, I notice I have opposite and adjacent, which would be the tangent of 53 degrees. It's going to be opposite over adjacent. So basically, I would just type into my calculator 14 times the tangent of 53, because again, I have to solve for x, and I end up with 18.6 for my x value. And again, I'm not going to pull up the calculator a whole lot on these because you can press all the buttons, and that way we can make sure we get to as many things as we can. Here, I've got adjacent and hypotenuse, which would be the cosine of 37 degrees. Adjacent over hypotenuse. Be careful. Some of you get going so fast, you'll do 5 times the cosine of 37 here. That's not right, because this time the x is in my denominator. So I'd have to multiply it to the other side, and what ends up happening is, instead now, my x is going to be 5 divided by the cosine of 37. Because if you stop to think about it, if I put the x over here, it's still not alone. Now I got to divide by the cosine of 37 to get it back by itself. And that's where my solution comes from. Again, it's the details. Here's my reference angle. Opposite over hypotenuse is sine. And now we're back to like we were over here, even though I mysteriously have lost number 9. Multiplying these together, 40 times the sine of 15 is 10.4, and I'm good to go. Okay. So then I work my way down here. What else have we got? Write trig ratios and solve to find the missing angles. Round answers to the nearest whole degree. So here, I say, okay, so I look, I've got opposite and I've got adjacent, which is tangent And I go ahead, I get those in. So remember, for that little -1, you're going to use second and tangent, and then just plug in the fraction. And again, we're going to the nearest whole degree, so it's going to be 29 degrees in this case. We get to this next one. I got adjacent over hypotenuse, which would be the cosine. And again, just to show you, I'll do it on 1 just to make sure that we're okay here. So again, we're in degrees. Do second cosine, that's why I put my little -1 in there to remind me. With an angle, I have to do the inverse. And again, if we're going to the nearest whole degree, it's going to be 51. So I keep bobbing along here, this is going pretty well. Support wire is being attached to a telephone pole 6 feet from the base. If the wire makes a 70-degree angle with the ground, find the length of the wire to the nearest tenth. Okay. So 6 feet from the base, we've got this wire going, okay. Wire makes a 70-degree angle with the ground. Find the length of the wire. Support wire to go like this. That would be the sine of 70 degrees. Is opposite over hypotenuse. Again, with x down here, we're going to be dividing by the sine. So x will end up being this, which means we're going to have about 6.4 feet in which that support wire's length is going to be. And again, with all of these, it's going to be like I say in every one of these, details are going to make or break you. So hopefully you take enough time to make sure you're in good shape with these. All right, skateboard ramp is 39 inches long and rises to a height of 22 inches. To the nearest degree, what angle does the ramp make with the ground? Opposite over hypotenuse. And we end up with a 34-degree angle. Other ones, again, we might just be given some information. We have to draw ourselves the particular angle. So if this is my A, sine is opposite over hypotenuse. Find the cosine. You just had to do that, Harty, didn't you? Which is adjacent. I got to figure this out. Yes. 121 minus 16 is 105, so that's the square root of 105. Adjacent over hypotenuse. That's what we're working with here. If the tangent of B equals 5, which is opposite over adjacent, because if I don't see the fraction there, I can always make it 1 by putting it over 1. Use the Pythagorean theorem, because I need opposite over, don't know the hypotenuse. 1 squared plus 5 squared is 26, which would be the square root of 26. Don't leave it that way. Rationalize it by multiplying both the numerator and denominator by the square root of 26, and we're good to go. Again, those are the types of quicker type things we need to be able to do to make sure we give ourselves time on this. 17. Find an angle with a positive measure and an angle with a negative measure that are coterminal with each angle. Remember, coterminal is plus or minus 360 degrees or plus or minus 2 pi. So if it's in degrees, that's cool. I can add 360. My positive would be 493 degrees. No, wait, wouldn't it be 473, you silly man? Negative, see, what I just talked about detail. 113 minus 360 is negative 247, and I'm ready there. Now, be careful. When you get to radians, do not put that in degrees and leave it that way. Bad, bad, bad. So, here, that plus or minus 2 pi, again, if I want it in sixths, would be 12 pi over 6, because 12 divided by 6 is 2. So when I plus or minus 12 pi over 6, I end up with 17 pi over 6 for my positive and negative 7 pi over 6 for my negative. And I'm good to go. But again, start in radian, end in radian. No exceptions. All right, 19. Rewrite each degree measure in radians and each radian measure in degrees. Again, degrees to radians times pi over 180. And then always, 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 always reduce. Don't leave it as 38 over 180. You can reduce that. Reduce it down as far as you can. So we've got math enter buttons or our brains for to start reducing these values down. But again, they'll always have pi, and if they have pi, of course, to get rid of it, we multiply by 180 over pi to go back into degree mode. 180 over pi to go back into degrees. All right, now we start kicking it up a little bit here. Little kid trig over, here we come. Find the exact value of the 6 trig functions of theta, which disappeared, if the terminal side in the standard position contains the point negative 2, 5. Okay, easiest way, draw yourself a picture. Negative 2, 5. That reference angle always is having its vertex at the origin, and this side of the triangle will always be on my x-axis. So once I get here, I'm like, okay, so negative 2 is left, 5 is up. And again, make sure you use the parentheses if you're going to type this in somewhere, but I don't think you need to. So 25 and 4 is the square root of 29. Remember what quadrant you're in. All students. Sine and cosecant are going to be the only ones that are positive over here. Everybody else is going to be negative. So sine opposite over hypotenuse, but again, I'll get that fixed. Cosecant is just going to be the inverse. I don't have to play that game again. Cosine is adjacent over hypotenuse. And again, I knew it was going to be negative because of this, but I also have the negative here to help me in case I forget. Negative square root of 29 over 2. And tangent, opposite over adjacent, or otherwise known as adjacent over opposite. But again, little things. Knowing the negative, knowing what quadrant you're in. Be on top of that. Because if you're not, that's going to make this very difficult on you. But it's all stuff we practiced and played with. Sketch the angle and find the reference angle. Now, would it be nice if we were really, really accurate here? Yes. But since we're in sketch mode, if you want to use your protractor, you can. If you're like, well, I know this is 90, I know this is 180, it's 20 more degrees, and that's approximately this far out, and I know that's 20 more, I'm okay with that. And then the reference angle, remember, it's back to the x-axis, the nearest one. So you're like, oh, well, 200 got me to here. Oh, it's this 20. Well, all right, 20 degrees is my reference angle. Whatever to get back to 180, 360, 0, whichever one of those x-axis points is the closest. Okay, 2 pi over 3. Now, some of you may want to look at this as an angle of degree measure when you start it. 2 times 180 is 360 divided by 3. It's a 120 degree angle. So there's my 90, there's my 180. I want a 120. So I go, hey, if that's 120, this is 60, and then 60 in radian form, start radians, and radians is pi over 3 is my 60 degree. And so that would be my reference angle. Okay, but always back to the x-axis. Okay, find the exact measure for each trig function. Now again, as you're doing these, you might find yourself with the ability to do some things simply since you have a sheet like this. So if you're looking for the sine of 120, remember, just keep them straight. Cosine sine, square root of 3 over 2. Exact means no decimals. No decimals, no. Okay, cosine, 5 times 180 is 900 divided by 6 would be like the cosine of 150. Negative square root of 3 over 2. Take advantage of the fact that you have the unit circle. Tangent of negative 240. Now think about that for a minute. If you were to think sketch-wise, negative 240, now you're going clockwise. So 90, 180, 240. Okay, there's 60 degrees right in here. You're like, oh, so 90. It's basically the equivalent of a 120 degree tangent measure, which you're right. Now, that gets a little trickier here because you look and you're like, now how does this work again? I don't remember how to do this. If it confuses you, here's your backup option. And by the way, if you remember correctly, tangent's going to be sine over cosine. So it'd just be this divided by this. Okay. And if that was the case, square root of 3 over 2 divided by negative 1/2 would be like timesing it by 2 over negative 1 would get me the negative square root of 3. But if you forget, you've got the 60 degree reference here. You could always do a 30, 60, 90 triangle. Negative 1, square root of 3, 2, and do opposite over adjacent and get the same thing. I'll zoom in for a second here in case some of you want to be able to see my mini triangle here that I sketched out real quickly. Okay, so that's what we're on the lookout for with ones like that. We have multiple options. Find the area of the triangle. Round to the nearest tenth if necessary. Now again, we're looking for area. Area you have on your sheet. You're going to take half the product of the lengths times the sine of the angle that's in between those two lengths. So here, I'm going to take half times 7 times 4 times the sine of 20 degrees. Should I be in radians or degrees still at this point? I should still be in degrees, because if I'm not, again, I'm going to get myself into trouble. .8 square centimeters. Might throw one in where you got to think a little bit. I gave you multiple angles this time, but remember, it's always the one that's between the two sides. So I'm going to use the 113. And get my area. So again, hopefully at this point you're going, yeah, this isn't bad. Especially having that sheet, if I need it, just in case, isn't a bad thing. All right. Find the missing angle or side for each triangle, round to the nearest tenth. Big fan of pictures. So let's see here. A is 62, B is 53. So let's see here. 62 and 53 is 115. So this guy is 65. So, and I know that C sides always opposite from their angles, is 5 meters. I want side B, this guy. Okay, so I have the sine of 65 over 5, corresponding angle and side, equals the sine of 53 over B. So B is just going to be 5 times the sine of 53 over the sine of 65. So let's go ahead and crank that out. 5 times the sine of 53 divided by the sine of 65. 4.4 meters. We're looking good. And again, when they don't give you triangles, sketch, 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 sketch. So 30 degrees, 422 feet. C is 310. We want to find angle C. So the sine of 30 over its corresponding side equals the sine of C over 310. Remember, with this one, we're looking for an angle. So when you go to type this in, remember, it's going to be second once I go looking. I may do this when I go to type it in a little bit differently than some of you, but I go ahead and I normally go ahead and type this part out knowing that that's not the angle, but that if I take the inverse of that particular value, that I am going to get the same solution. Oops, angle, Harty, angle. And again, we're rolling along here. Things are going pretty well. So I flip and I go, okay, I got a couple more of these to play with. I'm looking for side B. Probably should get my calculator out of the way here. So here, so I got A, B, C. I got side A, I got side C. I got angle B. So again, now I'm not going to be using the law of sines this time because I have two sides and their corresponding angle. So what we're going to do here instead is use the law of cosines. So we're going to look at this and say, okay, so I'm looking for B. So B squared is going to be the sum of the squares of my sides minus 2 times their product times the cosine of that included angle. And I type all of that in my calculator and then take the square root of it. So I can very safely type all this in. Again, for time's sake, we'll go ahead and get that typed in and find out side B is about 49.1. Well, what if they just give me all sides? I don't even need to draw a picture of this because it's not going to let me see very much. Remember, when you're doing these, okay, if I'm looking for A, I'm going to go ahead and use cosine of A for that. So I'm going to use 11 squared, 7 squared plus 14 squared minus 2 times this product. And since I want A, that's why we chose to start with the 11 squared, because I want the cosine of A. Now, a little different here, because I have to be a little bit more cautious. Well, what do you mean? Well, I go ahead, I'm going to multiply this out. Then I'm going to go ahead on the right side. I'm going to do my 7 squared plus 14 squared. And I'm going to do that part. Because all of this is connected to my cosine of A, my 2 times 7 times 14. Okay, can't subtract these. 196 is with the cosine of A. I'll subtract 245 over, though. So now I just take that remaining fraction and get to my answer that way. Okay, and I'm going to zoom back out here a bit because I like being able to see the whole sheet here. When we need to zoom back in, we will. So next, if the tangent of theta equals 1/2, my thetas are all disappearing here. Find the exact value of cosine given it's in quadrant 1, which just tells me it's still going to be positive. So, if we're in quadrant 1, and tangent opposite over adjacent is 1 and 2, tells me my hypotenuse is going to be the square root of 5. Find the exact value of cosine. Adjacent over hypotenuse, which again, when I rationalize it, ends up being 2 square root of 5 over 5, and everybody is positive in the first quadrant. So I'm good to go. Secant, now be careful here. If secant's 2 over 1, means cosine's 1 over 2. That may help out some. In the hint they give me, it's between 270 and 360. 90, 180, 270. So it's down here in quadrant 4. All students take calculus. You're like, wait a minute. Find the value of cosine. Hey, it's 1/2. It's just the inverse of secant. And since we're in cosine land, woohoo, I don't even need to worry about doing anything else. So don't make more work out of it than you have to if that leaves itself as a possibility. That won't happen every time, though. So let's keep rolling here. Okay, 90 to 180, we're in quadrant 2, all students, which includes cosecant, so this will be positive. Let's see. -8 over 17. Oops. Adjacent over hypotenuse, Harty. Hypotenuse. My Pythagorean triples tell me that my other leg will be 15, or I could use the Pythagorean theorem if I forget that. And again, cosecant is hypotenuse over opposite. Just my inverse assigned, and I'm good to go there. Simplifying expressions. Again, you have help available with your basic trig identities here, so don't fret over this. We like to make everything sine and cosine when we can. Cosecant, 1 over sine. Tangent, sine over cosine. Sines cancel. 1 over cosine is secant, and I'm done. So again, we try to leave sine alone, and we try to turn everything else into sine and cosine. Keeps life simple. When we're dividing, remember, tangent is sine over cosine. So since I'm dividing by it, though, it means I'm going to go ahead and take its inverse. Whack those guys, and once again we get cosine squared. But again, if it takes you a second to look through, you've got all the identities there, so take advantage of that. So next, find the amplitude, period, phase shift, and vertical shift. Notice, no graphing necessary. Amplitude, my A value, but again, it's the absolute value of A. My amplitude isn't -5. It's just 5. It's a distance. Distances are positive. Okay. My period, that 2 that's here, is like my b value. So it would be 2 pi over 2, which is just pi. My phase shift, again, my left-right phase shift is a liar. It's the opposite of what you would think. This is going to go right pi over 8. And then my vertical shift goes along with what we would think. It's up 3. That's all we need. All right, show all steps to verify the identity. We're rolling along pretty good here. Now, this one's not real pretty. This is the more complex side, so this is what we're going to try to turn into this. We're not going to touch this side. Can't do it. It's in a little bubble here. Can't go in the bubble. So, okay, I'm going to start working over here so we got a little more room to work with. I need a common denominator first because these, unfortunately, are not the same, which would be both of these. So, my common denominator is 1 plus the sine of t, 1 minus the sine of t. And to build my fraction again, I need this one in my first fraction. So I have cosine of 1 minus sine t plus the cosine of 1 plus sine t. Again, I'm just building my fraction. Whatever it takes to get from here to here, whatever I have already, great. Whatever I don't have already becomes another part up here. Distributing. Okay, I'm going to come down here first. So cosine t minus cosine t sine of t plus cosine t plus cosine t sine of t. All right, let's see what happens here. All over. Wait a minute. 1 plus sine, 1 minus sine. 1 minus sine squared t. That could come in handy. Here's something else I notice. Plus and minus cosine of t sine of t. That's good. So 2 cosine of t, because they didn't cancel out, over, 1 minus sine squared. I know what that is. Cosine squared. Cosine squared of t gives me 2 over the cosine of t, because we treat these like we would exponents. X over x squared would get me x down in the denominator. And then I could have 2 times 1 over cosine of t. Again, I can separate those. If I still multiply the 2 back, it'd still be the same thing I had. And then 1 over the cosine of t is secant. And I'm set. A little ugly, but it's not like we're giving you a bunch of these, so it's nothing that's too bad. But again, you might have to play with these. This is one that if you get stuck, you push it off till later and you come back and try to finish it a little bit after that if you need to. Don't sit on this for like 10 minutes. We're almost there. All right, 49. Given a central angle of theta 160 degrees and a circle of radius r equals 11 inches, find the length of the arc. Okay, so again, arc length, radius times theta. Be careful, theta. Now we're in radian world. Go back into the calculator, turn it back into radians. But also, turn your degree measures back into radians, which is more of what we're looking for. So here, we have 8 pi over 9 times 11. And we normally don't talk in language like 88 pi over 9, to be perfectly honest. I wouldn't mark it wrong if you did it. 88 pi divided by 9. So about 30.7 inches. Area of that same sector, 1/2 radius squared theta. So 1/2. My radius is 11, but I'm squaring it, which is 121, times my theta. Pop that all into the calculator here. So 121 times 8 pi divided by 18. Looks like 168.9 square inches, because now we're talking about area. We just keep plugging along. Almost there. Find the linear velocity if my radius is 12 meters and the point rotates at 100 revolutions per minute. Revolutions not in radians yet. Multiply it by 2 pi. Now we're in radians per minute. So again, my linear velocity as I look, oops, linear velocity. So 12 times 200 pi radians. And again, normally we're going to write this way. If you leave it as 2400 pi, again, I'm not going to mark it wrong because you're just being a little more exact. So that's all we'd be looking at on that. And finally, our favorite, graphing. So, accurately graph at least one period of the following. Label at least 5 ordered pairs. As long as you're telling me on the line what point that's at, that counts for me. That's fine. So let's see what we got here. We've got ourselves an amplitude of 2, a period of 2 pi divided by 1/3, which is 6 pi. We have no phase shift, no vertical shift, and since we didn't move anywhere else, our center line is going to be at 0. So I recognize we'll be going from -2 to 2 here. I also remember back to what my prototypical points all were. Because remember, we talked over and over about your base graph. 0, pi over 2, pi, 3 pi over 2, 2 pi. But now my period tripled. So I'm going to multiply all of those by 3. 3 pi over 2, 3 pi, 9 pi over 2, 6 pi. Those are my points. Those are the ones that I'm going to label because that's going to make it simpler for me to cover myself with my points. And then 0 will be my 5th. My amplitude just means I'm going to take my prototypical values that I would have had for y here, which for sine are 0, 1, 0, -1, 0, and multiply them by, be careful, I know the amplitude's 2, but multiply them by -2. So my new y would be 0, -2, 0, 2, 0. So 0, -2, 0, 2, 0. I connect the dots, okay? But again, if you understand your base graph, that's going to be much easier. If you try to do everything in the calculator, good luck getting those accurate pair points. So 52. This time we've got a cosine. My amplitude's 1. I don't see a value in front. My period is 2 pi divided by pi, which makes my period plain old 2. No vertical shift, but I have a phase shift of left 2. But still, since I have no vertical movement, my center line isn't going to move from 0. So I start to look at this and I go, okay, so this is basically my exact cosine graph, except now, instead of having these guys, I'm basically just losing the pi. Now, it may seem that this would be a good idea, except for one fact. We have to shift left 2. So, instead of using all of these, I can kind of try to squeeze some of this stuff in here. Maybe even try this. Let's see how this works out for me. Then I'll get little mini tick marks in the middle for my halves. So I'm like, okay, typically we'd be starting at 1, because again, when we're doing cosine with y values, it's 1, 0, negative 1, 0, 1. So I look and I go, okay, normally I start at 0, now I'm going to start at negative 2. So I'll start at 1. Then I'd go to a half. Okay. And as I'm doing these, gets me back to 0 here. Negative 1, 0, 1. And if I wanted to keep going, I can absolutely do that. Okay? But again, if you need to do a chart like we did in this first one, just to get your head thinking about it a little bit, you can. But you need to understand your base graphs. Your base theta, here's your base sine. And if you're looking for base graphs for cosine, just jot that down here just to kind of we spoke about these before, and then do all of your shifts off of it. That's absolutely something that you could do that would be worthwhile. Maybe going back and looking at the video or looking at your notes for this might help out too as well on this. Okay, all right, last page, here we come. So let's see here. Here my amplitude is 3. My period is 2 pi over that 4, so it's going to be pi over 2. I have a vertical shift of up 1, but I don't have a phase shift this time. And that up 1 is going to move my center line. Okay, lots of things to consider this time. Might even want to consider saying, okay, so my theta, the up 1 is going to affect my y value. My amplitude is going to affect my y value. My period, or my theta, is affected by this division. So I'm cutting all of my prototypical base parts in 4. So 0, pi over 2 is going to become pi over 8. Pi divided by 4 is pi over 4. 3 pi over 2 divided by 4 is 3 pi over 8. And 2 pi divided by 4 is pi over 2, which is where I should be ending up. Now, y is the part that gets interesting. So I'm actually going to start with my base, which is 0, 1, 0, negative 1, 0. But I'm going to do two things to it. Not only am I going to multiply it by my amplitude, then I'm going to add 1 to it. So we're going to do multiply by 3 and add 1. So my new y values will be at 1, 4, 1. Negative 3 plus 1 is negative 2, and 1. And now I'm ready to go. So pi over 8, pi over 4, 3 pi over 8, pi over 2. So at 0, I'm at 1. Pi over 8, I'm at 4. And again, with the labels, that's good enough for me. 1, negative 2, and back to 1. And we're good with the graphing. So